Bismillah ar-Rahman ar-Rahim. This question is chapter 8, 8-33. The man having a weight of 200 pounds, so his weight is 200 pounds. Pushes horizontally on the crate, so he's pushing horizontally, you can see it horizontally with the force P on this crate. If the coefficient of static of friction between the 450 pound crate, so this crate is 450 pounds, it's going down, it has a dimension of 2 times 3 feet. 3 feet is from the force, and the coefficient of friction is equal to 0.3, and between his shoes and the floor is, so his shoes and the floor has a friction, so he's pushing, so there's a friction between his shoes and the floor, 0.6. Determine if the man can move the crate. So let's analyze this question. First of all, we have to put the crate like this, 2 feet dimensions, and then the force from the man with a B, and 3 feet down, and of course you're gonna put the weight of the crate, 450 pounds, that way. Okay, and then once you are pushing the crate that way, you'll have a friction that way. You have friction on the ground, so this is the force of friction in the ground. And also there is a normal force on that point of friction. Let's just call this one point O. So let's call this one point O the friction, because you are pushing it that way, so the friction is going to be that way, and the normal force is going to be up. So let's find the normal force and Fc, and let's see that X, the distance between the position of the normal force and the center of the crate. So let's say this is 2 feet. So the middle is 1 feet here, 1 feet here. So the distance between the center of the crate and this point is X. So the crate by itself, if you do summation of forces in the X equal to 0, you'll have this force in the negative, and you'll have this force in the positive. So summation of forces of X equal to 0 minus B plus Fc equal to 0, which means that B is equal to Fc. So the point P, the force from the human pushing the crate, so this force from the human on the crate is equal the friction down there, opposite. So this is force, this is friction of the movement of the crate. Okay, so let's do summation of force at the Y. You can see that here there is no Y, here there is a Y down there, 450 negative, and you have a normal force positive. So in the negative, and the summation of force in the Y equal to 0, NC minus 450. Number 450 is going down because this is the weight of the crate, it's going down. So NC minus 450 equal to 0, NC is equal to 450 pounds. So we know that the normal force here is equal to 450 pounds. Now, we need to find a relationship with the X, so let's find a moment at point O. If you find the moment at point O, which means that Fc and Nc will be cancelled. So you can see moment at O, the 450 pound gonna pull the container or the crate that way. So this is the negative, minus 450 times, what is the distance? X. So minus 450 times X. And plus there is a force P, if you have, if you nail it that way, so this force will push it a positive. It will make the crate goes like this, counterclockwise. So it is P times 3. You can see the distance, P times 3. This is the distance between point O and P. So P times 3 equal to 0. Now we have one equation, second equation, and this equation is solved, and C is equal to 450. Now this is the crate. Let's analyze the human by itself. Let's see the human. What are the forces in the human? Remember, he told you that the weight of the human is 200 pounds. So the weight of the human is 200 pounds. So we'll make the human, his face, his hand, and his legs. So the weight is at the center of the human, 200 pounds, and it's going down, of course, that's the weight at gravity. And remember that there is a force P, he's pushing, and of course there will be a force P from the crate to the human. So there's a force opposite, Newton law, opposite in direction, same magnitude, going back to the human. And of course the human will have a normal force and will have a friction force. So there's the friction force in his legs on the floor, and there is also a normal force. Okay, So there is 1 in the positive x, there's 1 in the negative y, there's 1 in the negative x, and there's 1 in the positive y. So let's do summation of forces at the x equal to 0. B minus Fm equal to 0. So B equal to Fm. This Fm is the friction because of the man, and this is normal because of the man, and man, force man. Summation of forces of y equal to 0, Nm minus 200 equal to 0, which means that the normal force for the man is 200 pounds. Now, he gave you the static, the friction forces, okay? He gave you the friction coefficient, sorry. He gave you the coefficient for, mu s 0.3 for the crate and mu s slash 0.6 for the humans. So, the force of friction, because of friction, the Fc is equal mu c, this is from the crate, times Nc. So Nc times the friction is equal to Fc. So Fc, the friction because of the crate, is equal the normal force times, this is by default. So mu s, we know it, it's 0.3. It's 0.3. Okay, you see it 0.3? Okay. So 0.3 times Nc. What is the normal force? Normal force was given to be equal to, remember the normal force because of the crate, it's equal to 450. So this would give you 1,135 pounds. So this is the force because of friction. And now we know that from here, from this equation, that's minus B plus Fc equal to 0. And we know that Fc is equal to 135. So this is Fc, and we could find P now, because P is equal to Fc. So P is equal to 135 pound. Okay? So you could go to the next equation. 3B. Now we found B. B is 135 pound. So 135 pound times 3 minus 450x. So now we could find x. So x will be equal to, you do it like this. X is equal to 0.9 feet. So now we found x, we found Nc, Fc, and we found P. What now? We should look at this. If it is less than 1, if x less than 1, the crate slides before tipping. It will slide. So x is 0.9, and of course the center of the crate is 1. So 0.9 is less than 1. So the crate will slide before tipping. And also the human. Now let's look at the human. If the friction force, which is, what was the Fm? The Fm that we just found, Fm is equal to 135. Fm, of course, Fm is equal to P. Fm is equal to P, and Fm is equal to B is equal to 135. P is equal to 135. Okay? So the Fm, if it's greater than the friction force max, which is mu s dash times normal force because of the man, 0.6, okay, times the normal force because of the man, Nm, and Nm is equal to 200. So 200 times 0.6, you'll get 120 pounds. So 135 is more than 120 pounds. So the man slips, he cannot move the crate. Okay? So this is the question 8-33. Okay, 8-33.